Hi, it's me again. This time we are talking about virtual slats and custom modules, so that even if your firing system doesn't support hardware virtual slats, you can create virtual ones and use them. And in this section I show you how.
As you saw in the last chapter, some firing systems are able to use special hardware called slats. But what about the other systems that does not support this kind of hardware like the Pyrotronics or Cobra? Even the Cobra system that has hardware slats does not include a slat address, they only include module and pin. But Finale has also a solution for this systems that is called virtual slats. A virtual slat is a user-defined distribution box or rail for a module's electrical terminals, which is not explicitly represented in the firing system script file. Of course, this gives you not the ability to extend the terminals away from the module, but it is possible to partition the pins on the module into different groups. To use such kind of slats you must define a custom module. So please open Addressing from the main menu, then click Addressing Settings, and then Custom Module Specification. We start to define a slat for a Pyrotronics system, but it is nearly the same for other system like the Fire one. So, first select the firing system for which you want to define the module. Now look at the next line, the rail address template. The template tells Finale how to split addresses into modules, slats and pins. At the moment this template exists of two parts that are divided with a slash. The first part defines the maximum number of modules that can be used by the system. In this example the maximum is set to 99. The second part specifies the number of pins, in this case it is set to 16. To add slats to the template we had to add a character to the template like it is done at the example at the bottom of the screen. So we enter a slash at the end of the number of modules, and then we add a B to divide the module in two parts. Because a Pyrotronics module has only 16 pins, a division into two parts mean that we have now two parts on the module with 8 channels. In our case you can imagine that the left part of a Pyrotronics module is now the slat 1, the right part is slat 2. Let's see how this works with an example. So let's click Enter to save this definition for our module and look at the following demo show with 16 effects. There are only 2 different effects in it, each effect 8 times, but the order of these 2 effects is random. So, when we address this with a normal module we will get the following result. Look at the pin numbers in the effects, you see the randomness, what means that in reality you must take care which effect is to wire on which pin. Let's go a little bit further and use our new custom module. To have an advantage of this slat, we use a slat constraint that is grouping the slats to the different part numbers. Click Enter and see what happens. First we see a different presentation of the rails, but QA's now the slat is added, in our case A and B. When we sort for rails we see the advantage that we have got now. The A slat from pin number 1 to 8 is assigned to the same article and the pin number 9 till 16 are assigned to the other effect. This will make setup more easier and reduce the wiring errors, because if you make a mistake and connect pin 1 to pin 4 and vice versa it will have no impact on the show, because all effects on the slat 1 will have the same effect. But even if you don't use slats, custom modules can make your life easier. So, for example, let's say Cobra came out with a new 6-channel module and this is not implemented in Finale. No problem, you can create a custom module to specify it. So, go again in Addressing Settings, and then Custom Module Specification. This time choose Cobra as firing system. In the template just replace the 18 with a 6. To test it, press Enter and address the show again with Cobra and the custom module as module type. Please make sure that the slat constraint is not set this time. From the result you can see that now 3 modules are needed. Sometime this trick makes also sense to limit the number of pins so that the module fits on a rack without wiring to another rack. To show you, I address with a Pyrotronics system and a normal 16-channel module. Look at the rack layout and the wiring there. If our rack has 15 tubes, so the module is also responsible for the second rack, and there is a need for a cross cable from one rack to the other if the module is fixed on a rack. Very ugly. One way to solve this is to define a custom module with only 15 pins. Let's do that. Just remove the slat part in the template and set the number of channels to 15. Address the show again, this time with a Pyrotronics custom 15-pin module. When finished, look at the rack window again. You will now need 2 modules, but the setup will be a lot cleaner.